The universe begins in silence, a silence so vast it swallows even the idea of sound. Across this endless dark, galaxies drift like lanterns adrift on a black ocean, each one a glowing isle of stars, yet each one receding, slipping farther and farther away. It is as though some invisible hand pushes them outward, urging separation, commanding distance at first glance. The cosmos seems calm, still, eternal. But hidden beneath its velvet surface lies an unsettling truth. The expansion of the universe is not slowing. As gravity would suggest, it is accelerating every second. The gulf between galaxies grows wider every moment. The light of countless suns stretches thinner across the abyss. This is the paradox that haunts modern science. If gravity binds, what unseen force unbinds? If matter pulls together, what power drives it apart? In the grand theatre of creation, a silent actor moves behind the curtain, unseen, unmeasured, and unnamed. Yet it sculpts the destiny of everything. Astronomers call it dark energy, but the name is only an admission of ignorance. It is not darkness, nor energy as we know it. It is the phantom breath of the cosmos, the hidden ruler of expansion. And so the question echoes across observatories, satellites, and minds alike. What force is tearing the universe apart, faster and faster? And what fate awaits a cosmos driven into endless flight? If you are new here, join the journey. Like, subscribe, and let's begin. It began quietly, with the patient eyes of astronomers turned toward the dying embers of stars far away. In the late years of the 20th century, a simple expectation guided their work, that the universe, born in a single burst of fire and expansion, must even now be slowing in its outward flight. Gravity, they reasoned, the great binding hand of the cosmos, could not allow galaxies to drift forever without restraint. Over billions of years, that gentle pull would surely draw them back, or at the very least, soften their escape into stillness. The task seemed straightforward, almost inevitable. If the universe had exploded into being nearly 14 billion years ago, then by measuring how much its expansion had slowed since, one might calculate its ultimate fate. Would it collapse into a fiery end, a big crunch? Or would it coast forever into the cold? To answer, scientists turned to the most reliable of cosmic candles, the brilliant explosions of distant stars known as Type Ia supernovae. These stellar deaths are so uniform in their fury that they burn with a predictable brightness, like lanterns scattered across the abyss. By comparing how bright they appear with how bright they must be, astronomers can judge not only their distance, but also the speed at which the universe has carried them away. Two great teams formed, separated by continents yet joined by purpose. In the United States, the Supernova Cosmology Project, led by Saul Perlmutter. In Australia and Chile, the High Z Supernova Search Team, under Brian Schmidt and Adam Rees. They armed themselves with the sharpest tools of their age, the Hubble Space Telescope, with its view above the trembling atmosphere of Earth, and the great ground-based observatories of the Southern Hemisphere, which scanned skies rich with galaxies. For years they gathered faint glimmers of ancient light, sometimes chasing a single star that flared for only weeks before fading into silence. At first, the results trickled in just as expected. The expansion seemed steady, measurable, the stars obedient to prediction. Yet as more data filled the archives, a whisper of unease began to form. Distant supernovae, those flaring in galaxies billions of light years away, whose light had traveled across epochs, appeared strangely dim, not slightly, not by chance, but consistently dimmer than theory allowed. If these cosmic lighthouses were farther away than expected, then something was wrong with the great clockwork of the cosmos. By 1998, the whisper became undeniable. Both teams, working independently, reached the same unthinkable conclusion. The universe was not slowing. It was not coasting. It was accelerating. The galaxies were being pushed apart faster and faster, as though driven by an unseen and relentless hand. The revelation landed with the weight of heresy. For nearly a century, since Edwin Hubble had shown that galaxies recede from one another, scientists had assumed expansion must diminish under the pull of gravity. The image of a slowing universe was carved into textbooks, embedded into equations, trusted like scripture. To learn instead that expansion was racing forward, gaining speed against gravity's pull, was to discover that something vast and unmeasured was at work, in the very fabric of reality. The term came quickly, cautious yet unavoidable. Dark energy, an invisible force filling the void, accounting for nearly 70% of the cosmos, yet never before noticed. It was not an answer, but a placeholder, a word that disguised ignorance with the promise of explanation. What this energy was, no one knew. Only its fingerprints, the dimming of supernovae, revealed its presence. The world of physics reeled. Some looked to the past, recalling Einstein's cosmological constant, a mathematical adjustment he once inserted into his equations of general relativity to keep the universe from collapsing. He later abandoned it, calling it his greatest blunder. But now perhaps it was no blunder at all. Perhaps it was prophecy. Others searched the quantum vacuum, the restless seething of particles that flicker in and out of nothingness. But calculations diverged wildly, predicting an energy density unimaginably higher than what observations allowed. The discrepancy was not a detail. It was the greatest mismatch between theory and reality in the history of science. And yet, the data would not bend. Supernova after supernova confirmed the result. Instruments improved, surveys widened, skepticism turned to reluctant acceptance. The cosmos itself was telling a story that no one had expected to hear. In 2011, the discovery was honored with the Nobel Prize in Physics. Saul Perlmutter, Brian Schmidt, and Adam Rees were recognized for unveiling a universe that defied expectation, for finding that the stars themselves whispered of a force no eye could see. But the Nobel was not for solving the mystery, only for revealing it. For even now, decades later, dark energy remains nameless and unknowable. Its nature is unmeasured, its cause unimagined. All that is known is its effect. The galaxies rushing apart in a silent race, the universe stretching faster with every passing age. It was an unwanted surprise, and it left physics humbled. The universe had revealed not certainty, but a wound in understanding. What was thought to be a closed story, the history of expansion since the Big Bang, was instead the opening of a deeper riddle. In the glow of ancient supernovae, humanity learned that its picture of reality was partial, perhaps fragile, and somewhere, beyond the reach of light, the true nature of dark energy waited, unseen, like a shadow against the stars. The universe had always been imagined as a vast arena governed by a single unwavering master: gravity. Since Isaac Newton had traced the fall of an apple to the same law that binds the moon in its orbit, gravity had reigned as the most trusted of forces. It was steady, predictable, the silent hand shaping stars, galaxies, and the paths of worlds. And when Einstein reshaped it into the elegant geometry of space-time itself, the conviction only deepened. Gravity was not a mere force pulling at matter. It was the curvature of reality, the scaffolding of the cosmos. If anything in science could be relied upon, it was gravity. Yet in the dim glow of distant supernovae, gravity appeared to falter. The numbers told a story that contradicted centuries of intuition. Instead of pulling galaxies back, gravity was losing its grip, as if the very skeleton of the universe had betrayed its promise. Expansion was not slowing, but quickening, a truth both astonishing and unbearable. For cosmologists of the late 20th century, this revelation was not just a puzzle, it was a rupture. For decades, they had argued only about the rate at which the cosmos was slowing. Some believed it would one day reverse, collapsing into a fiery big crunch. Others imagined it would slow but never halt, coasting forever in a gentle decline. These were the boundaries of debate: collapse or coast, fire or silence. Now both visions were undone. A third destiny, unimagined, had arrived, a universe racing away faster and faster, into infinite darkness. The shock carried echoes of an older story, a moment when Einstein himself had faced the possibility of a changing cosmos. In 1917, while applying his equations of general relativity to the universe as a whole, he encountered a troubling implication. His theory predicted that the cosmos could not remain static. It must expand or contract under the sway of gravity. Yet the prevailing belief of the age was that the universe was eternal and unchanging, a fixed stage upon which stars and galaxies merely drifted. To rescue his equations from this unwanted truth, Einstein inserted a delicate term: the cosmological constant, a hidden counterforce, finely tuned to balance gravity, keeping the universe stable. But the illusion did not last. In 1929, Edwin Hubble revealed that galaxies were receding from one another, the universe expanding like the surface of a balloon. The need for balance vanished. Expansion was real, not theoretical. Einstein discarded his constant and reportedly called it his greatest blunder. And yet, in the 1990s, the constant returned from the grave. For what the supernovae revealed was not merely expansion, but acceleration. Something stronger than gravity was at work, woven into the void itself, driving galaxies apart. The cosmological constant, once abandoned, now offered a tempting explanation. A uniform energy that fills all of space, invisible but real. The irony was sharp. Einstein's discarded invention now stood as the simplest answer to the universe's betrayal. But even this explanation brought no peace. For if the constant were real, its strength must be measured. And here lay the greatest dissonance of all. Quantum field theory, the language of the microscopic world, predicts that empty space is not empty at all. The vacuum seethes with fluctuations, particles flickering into being and vanishing again, a restless sea of quantum foam. This vacuum energy, when calculated, should act as a cosmological constant. But the numbers do not align. In fact, they differ by a staggering factor, 10 to the power of 120. It is the largest mismatch between theory and observation ever encountered, a chasm so vast it dwarfs all other discrepancies in physics. To call it an error is insufficient. It is an abyss carved into the heart of science. The shock deepened further when cosmologists realized what this meant for the cosmic ledger. If acceleration were true, then most of the universe was composed of something unseeable. Only about 5%, the stars, planets, gas, and dust, belonged to the familiar world of atoms. Roughly 27% was assigned to dark matter, the invisible mass that binds galaxies but has never been directly observed. And the remaining 68%, the largest share, was now attributed to this new ghostly driver, dark energy, a name without a nature, a shadow that outweighed everything known. For scientists, such an outcome bordered on the unbearable. The human mind had spent centuries assembling the clockwork of the cosmos, only to learn that nearly all of it was hidden behind a veil, that the very fate of the universe was dictated by something neither measured nor understood. Skepticism followed, as it must. Could the data be flawed? Were the supernovae misunderstood? Some argued that dust or cosmic evolution might dim the stars in ways not accounted for. Others suggested systematic errors in observation, but the evidence multiplied relentlessly. The cosmic microwave background, mapped by satellites like WMAP and later Planck, carried the same whisper. The distribution of galaxies, traced across billions of light years, spoke with the same voice. Everywhere the universe was measured, the same betrayal was found. Acceleration was not an error, it was reality. This confrontation left cosmology in a strange limbo, certain of the effect, uncertain of the cause. The laws of physics had not broken, but they seemed insufficient, incomplete. Gravity, once sovereign, now appeared humbled, challenged by something deeper, something that dwelled in the emptiness between galaxies. For the scientific community, the first whispers of dark energy were both a confession and a defiance. To give it a name was to admit ignorance, but it was also to claim the mystery, to mark the unknown as territory to be explored. Dark energy was less a theory than a placeholder, an empty vessel waiting to be filled with meaning. Philosophically, the shock rippled outward. If gravity could not be trusted on the grandest scales, what else might falter? Was the universe stranger than even Einstein had feared? Was the story of the cosmos not one of order, but of incomprehension? For millennia, humanity had sought to tame the heavens with mathematics, believing that nature could be written into equations. But here was a reminder that reality may hold secrets beyond the reach of logic. And so, the late 20th century closed with a paradox. The most trusted force of nature, gravity, was no longer sufficient to explain the fate of the universe. The most successful theory of the microscopic world, quantum mechanics, offered predictions catastrophically wrong. Between these two pillars, in the silence of deep space, stretched a question that betrayed every expectation. The universe, it seemed, was not bound by the rules humanity had so carefully written. It was expanding into mystery, accelerating into silence, fleeing beyond comprehension, and somewhere, in that unseen acceleration, lay the first whispers of an answer humanity had not yet learned to imagine. The shock of discovery left cosmology trembling, But science does not rest with astonishment. It listens again, it measures again, it turns back to the sky with sharper instruments and deeper patience. For if the universe had revealed an impossible truth, that expansion was quickening instead of fading, then new eyes were needed to confirm it. Eyes that could listen to the oldest echoes and trace the faintest fingerprints of creation itself. The first step back into clarity began not with stars, but with silence. In 1965, two radio engineers, Arno Penzias and Robert Wilson, tuning their antenna in New Jersey, stumbled upon a faint hiss that would not vanish. At first, they blamed pigeons nesting in the dish, but the noise remained, no matter what they tried. What they had heard was not noise at all, but the oldest light in the universe, stretched thin by billions of years of expansion. A remnant of the Big Bang, still whispering across the cosmos. This light became known as the cosmic microwave background, the CMB, a veil of radiation that fills all space, the afterglow of the universe's fiery birth. Decades later, satellites would be launched to study this faint glow with precision unimaginable to earlier generations. In 1989, NASA sent COBE, the Cosmic Background Explorer, to orbit Earth. Its instruments revealed the CMB to be astonishingly uniform, yet laced with minute ripples, tiny fluctuations in temperature, only millionths of a degree. These ripples were the seeds of structure, the first fingerprints of the galaxies and clusters that would one day emerge. After COBE came WMAP, launched in 2001. It sharpened the cosmic portrait, mapping the entire sky with unprecedented detail. And then, in 2009, the Planck satellite of the European Space Agency carried the story to its finest precision yet, charting the faint echoes of creation with exquisite accuracy. These missions confirmed more than the birth of the cosmos. They provided a cosmic inventory. By studying the patterns in the CMB, the spacing of peaks and troughs in its spectrum, cosmologists could weigh the universe itself. The verdict was startling. Only about 5% of the cosmos consisted of ordinary matter, atoms, the building blocks of stars, planets, oceans, and life. Roughly 27% was invisible mass, a shadow substance called dark matter, whose gravity bound galaxies but emitted no light. And the remaining 68%, the overwhelming majority, was something wholly different. The unknown agent driving cosmic acceleration, now called dark energy. The universe, once thought to be luminous and knowable, was revealed to be mostly hidden, a stage lit by stars, but built on shadows. Yet the CMB was not the only messenger. Another voice emerged in the large-scale clustering of galaxies, the vast filaments and voids that form the cosmic web. When astronomers mapped the distribution of galaxies across billions of light-years, they found patterns written into the very structure of space. A faint ripple, an echo of primordial sound waves that once rippled through the plasma of the young universe, remained imprinted in the positions of galaxies today. These ripples are called baryon acoustic oscillations. Like frozen sound waves, they are a ruler stretched across the cosmos, allowing astronomers to measure distances with precision. By comparing the scale of these oscillations across different epochs, scientists could trace the expansion of the universe with a new kind of accuracy. And again, the message was the same. The expansion was not slowing, it was accelerating. Every layer of observation, independent and precise, told the same story. From the faint hiss of the CMB to the grand architecture of galaxies, from the ripples of sound to the light of dying stars, the cosmos whispered in unison. The universe is driven by something unseen. This concordance, the agreement of independent methods, deepened the mystery rather than resolved it. For now, the evidence was no longer fragile. It was not confined to the dimming of supernovae. It was woven into the fabric of cosmic background radiation, etched into the clustering of galaxies, measured in the distribution of matter itself. Acceleration was real, universal, and measurable, and yet no known force could explain it. The implications were profound. The familiar 5%, the luminous matter that had shaped human imagination for millennia, was reduced to a cosmic minority. All the stars, all the galaxies, all the fires of the heavens were only a surface detail upon a deeper reality. The true rulers of the cosmos were hidden, dark matter and dark energy, neither touched by light, neither understood. The Planck mission offered even greater precision, refining the age of the universe to about 8 billion years, and locking the proportions of its components into a sharper portrait. But with clarity came discomfort. For the numbers only reinforced the enigma. The universe was accelerating, and no equation, no theory, no particle could account for why. This was the silence that haunted cosmology at the dawn of the 21st century. Not silence of ignorance, but silence of confirmation. The universe had been weighed, measured, and mapped. Its history traced back to the first light, its large-scale structure catalogued with astonishing accuracy. And yet, the heart of the mystery only grew darker. Dark energy did not fade under scrutiny. It sharpened. It became not a tentative possibility, but the dominant feature of the cosmos. A feature with no known cause. A whisper that grew louder with every new instrument, every new survey, every deeper glance into the abyss. For scientists, this was both triumph and torment. Triumph, because the universe had been charted with a precision unimaginable to Einstein, or even to Hubble. Torment, because that precision revealed a truth they could not explain. It was as though the cosmos had handed them a perfect map, only to leave the destination unnamed. Philosophically, this was a revelation of humility. The universe, once thought to be governed by visible stars and galaxies, was revealed to be guided by invisible forces. The human eye, evolved to see light, was blind to the majority of existence. The mind, shaped by earthly gravity, could not fathom the dominance of something that repelled rather than pulled. Every layer of data deepened the mystery. The universe was not only stranger than imagined, it was stranger than could be imagined. And in that strangeness lay both the burden and the promise of science. The cosmos had spoken, in echoes of ancient light and ripples of frozen sound. It had confessed that most of itself was hidden, that its fate was ruled by something unseen, and humanity, standing at the threshold of comprehension, was left with the task of listening more deeply still, searching for a language in which the silence of dark energy could finally be translated into meaning. The numbers on the page did not tremble. They were calm, precise, almost indifferent. And yet behind those silent digits lay a story so vast, so merciless, that it seemed to betray the very hope humanity had placed in the cosmos, for the data now spoke of a universe not only expanding, but accelerating. An expansion that showed no sign of slowing, no gesture of restraint, no promise of return. It was as though the universe itself had chosen a path away from everything it had ever built, a retreat into coldness, into silence, into inevitability. At first, the conclusion seemed impossible. Every known law of physics taught that gravity must win in the end. Stars would burn out, galaxies would fade, but the embrace of matter should always pull creation back into itself. Yet the evidence did not bend to expectation. Distant supernova, the cosmic microwave background, the grand clustering of galaxies, all told the same tale: the cosmos was running away, and faster with every passing moment. This acceleration was not wild or uneven. It carried a strange serenity, a terrifying order uniform across the heavens, indifferent to galaxies, to clusters, to entire filaments of matter. The expansion appeared everywhere, in all directions, as though written into the geometry of space itself, and in that realization, a new fear took hold. If it continues, then the future of all things is not gathering, but dispersal, not unity, but solitude. Astronomers began to cast their gaze forward across the ages still to come. They saw the outlines of destinies more haunting than myth in one vision. The expansion endures forever, never pausing, never reversing. Galaxies beyond our cosmic neighborhood would slip away, their light redshifted beyond reach, fading until they vanish from the observable sky. Each one carried past a horizon from which no signal could ever return, the Milky Way would remain, but increasingly alone, a single island of stars adrift in a deepening sea of black. This fate is called the Big Freeze, not a death in fire, but in stillness the stars would exhaust their fuel, one by one, and darkness would replace their brilliance. Planets would grow cold, drifting in orbits without warmth. Even the black holes would eventually evaporate through the slow whisper of Hawking radiation, leaving only ghostly particles in an endless, empty night. A universe stretched so thin that nothing new could ever form entropy victorious, silence eternal, but there was another vision, more violent, more catastrophic. If the force driving the acceleration, this enigmatic dark energy, were to strengthen with time, it could grow fierce enough to tear apart everything it once carried. This scenario is called the Big Rip. Galaxies would disintegrate first, their bonds undone by the swelling pace of expansion. Then stars, then planets, until the very atoms themselves could no longer endure. Molecules would unravel, protons would burst apart, and even the fabric of space and time would collapse into fragments. A cosmos that ends not in fading silence, but in shattering. Between the quiet abyss of the Big Freeze and the apocalyptic fracture of the Big Rip lies the unknown, both futures written not by myth, but by equations, both whispered by the mathematics of expansion, both equally unyielding. The terror of this discovery was not only in its cosmic scale, but in its intimacy, for it meant that every star ever seen, every galaxy mapped, every nebula admired, all carry within them an expiration not in fire and collapse, but in slow dissolution. The very act of existence had been revealed to be temporary. And yet within this revelation lies a paradox of beauty, for the same acceleration that promises cosmic solitude is also the reason the universe exists as it does today. Without it, galaxies might have collapsed too swiftly, stars may not have had the time to forge elements, nor planets to gather their dust. Life itself may never have emerged to wonder at the stars. The terror and the miracle are bound together, inseparable, each a consequence of the same invisible hand. The discovery began as a question of numbers, a search for the rate of cosmic slowing after the Big Bang. But it became a prophecy of destiny, one written not by the will of gods or the imagination of poets, but by the silent drift of galaxies in the dark and still. The nature of the force remains unknown dark energy, a name chosen not to describe, but to admit ignorance. It is everywhere, yet invisible. It shapes the future, yet resists all attempts at understanding. Astronomers, physicists, cosmologists, all stand at the edge of knowledge, staring into equations that speak of endings they cannot yet explain. It is a mystery wrapped into the structure of reality itself, a riddle that asks, why does the universe hurry away from itself? What summons its acceleration, and what final silence awaits when all distance grows infinite? The escalation is not merely scientific, it is existential. For to learn the universe accelerates is to confront the possibility that time is not a circle nor a balance, but a one-way path into nothingness. The stars will not gather again, the galaxies will not return. The expansion is both cradle and grave. The terror lies not only in the numbers, but in the quiet certainty they carry a destiny vast enough to erase every memory, every story, every spark. The cosmos does not rage, it does not roar, it simply drifts, and in that drift, all things are undone. This was the unwanted truth of acceleration, a revelation that began with faint supernovae and ended in visions of eternity. The universe, it seems, had betrayed its own promise not to collapse, not to endure, but to scatter, to stretch itself beyond recognition, to leave nothing behind but the faint echo of a beginning, fading into silence. The story of cosmic acceleration is not only a chapter in science, it is a reminder of the fragility of everything, of galaxies, of stars, of life, of the strange and fleeting moment in which the universe allowed itself to be seen for one day. Perhaps it will no longer permit even that. The universe had confessed its secret, a cosmos not slowing but accelerating. Yet to name a mystery is not to solve it, and so scientists began the long and uncertain ritual of explanation. They called it dark energy, a title less of knowledge than of surrender, a phrase that acknowledged the presence of something vast, invisible, and unknown. like a phantom inhabiting the very fabric of space-time. But naming was only the first step. Understanding would require wandering through the deepest halls of theory, revisiting ghosts of abandoned ideas and daring to imagine forces stranger than anything previously conceived. One spectre rose immediately from history: Einstein's forgotten constant A term he had once inserted into his equations to hold the universe steady. The cosmological constant, an invisible pressure born not of matter, but of empty space itself. When Hubble revealed that galaxies were receding, Einstein abandoned it, calling the constant his greatest blunder. Yet now it returned, with unsettling grace, for if a constant energy pervades the vacuum, unchanging and eternal, it could explain the uniform acceleration observed in the sky. It was a solution simple in form, yet haunting in implication: the vacuum itself. The nothingness between galaxies was not truly nothing. It carried energy, and that energy had power enough to bend the destiny of all things. But the simplicity did not last. Quantum physics, that restless architecture of the small, insisted the vacuum should be alive with fluctuations. Particles endlessly appearing and vanishing, fields trembling at every scale. From this chaos arises what is known as vacuum energy, and here lay the catastrophe. The numbers, when calculated, did not whisper agreement with observation. They screamed disparity. The energy, predicted by quantum theory, exceeded the measured value by a factor of 10 to the power of 120, a mismatch so staggering that it has been called the worst prediction in all of science. The cosmological constant seemed plausible. Quantum vacuum energy seemed inevitable. Yet together they revealed a wound in physics so deep that no bridge could span it. Others turned to speculation more fluid. Less rigid than a constant, they imagined a field not fixed, but dynamic and energy that could evolve with time, changing its strength as the cosmos expanded. This was quintessence, a name borrowed from the ancient philosophers, who believed the heavens were composed of a fifth element. Beyond earth, air, fire, and water, modern quintessence would be a cosmic field, filling all of space, its density shifting as the universe aged. Unlike a constant, it could grow, diminish, or even vanish entirely. It opened the possibility that acceleration was not eternal, but a phase in a larger story. Yet even here, the equations remained slippery, for quintessence required assumptions about how such a field would move, how it would interact, and why it should exist at all. No evidence beyond the acceleration itself offered support. It was a theory of necessity, not of proof. Some ventured further still, into darker terrain. They envisioned a universe ruled by phantom energy. Here the acceleration would not merely continue, but increase without bound. The fabric of space would stretch faster and faster, until no bond could endure. Galaxies would be torn apart, stars ripped from their orbits, planets shredded, even atoms dismantled, their nuclei unbound, their particles scattered. It was a vision of the Big Rip carried to its ultimate mathematics. An apocalypse written not in myth, but in calculation. Though speculative, it revealed the stakes of misunderstanding the phantom. For if dark energy were of this nature, then not even matter itself would survive its hunger. And then came a different whisper. Perhaps it was not an energy at all. Perhaps the error lay not in the emptiness of space, but in the laws that described it. Could it be that gravity itself misbehaves on cosmic scales? In these theories, Einstein's equations remain magnificent but incomplete. The general relativity that rules planets, stars, and galaxies might falter when stretched to the dimensions of the entire universe. New terms, new forces, perhaps even new dimensions of existence could alter how gravity pulls and how space curves. Such modified gravity theories held a seductive appeal. They did not require invisible phantoms, only a willingness to accept that the known laws were not final. Yet every attempt so far has stumbled against the same challenge. General relativity, tested to exquisite precision within the solar system and around black holes, has never failed. To alter it without breaking its successes has proven near impossible. And so, the theories gather like shadows on the horizon. The cosmological constant, elegant yet unsatisfying; the quantum vacuum, precise yet catastrophically wrong quintessence; graceful but unproven phantom energy; terrifying but speculative modified gravity; bold but inconsistent. Each offers a fragment of truth, But none commands the whole. Each opens doors to possibility, but leaves others shut in defiance. The phantom remains unnamed, even as names are given. The struggle is more than academic, for within this enigma lies the ultimate fate of everything. If the constant rules, then the big freeze awaits. If quintessence evolves, perhaps acceleration will one day relent. If phantom energy grows, the cosmos is destined for shattering. If gravity itself shifts, the very blueprint of space-time must be rewritten. No theory yet explains why the magnitude is so small, why the acceleration began so late in cosmic history, why it acts with such uniform precision. These questions remain suspended, unanswered, like stars beyond a horizon in the halls of science. The phantom has become a mirror, reflecting the limits of knowledge, the fractures between quantum mechanics and general relativity, the unfinished symphony of physics itself. Dark energy is not only a puzzle of astronomy, it is the fault line of modern theory. The silence that reveals how much remains unknown for now. The universe accelerates and humanity is left naming shadows, assigning form to mystery, crafting equations to capture what cannot yet be grasped. The phantom is everywhere, in every distance between galaxies, in every empty stretch of sky, in every horizon receding into night. A presence without substance, a force without face. It carries the future. It holds the fate of stars and it waits, still nameless, in the dark. The mystery of dark energy does not linger in silence alone. It is pursued by eyes more powerful than any the human body could grow. Eyes built from glass, silicon, and mirrors of impossible polish eyes that stare into the abyss of time and return with maps of the unseen. For science has chosen to fight its ignorance not with denial, but with vigilance, to measure what has no face, to weigh what cannot be touched, to chart the ghost that bends the destiny of the cosmos. The European Space Agency has sent one such, eye into the void, Euclid, a telescope launched with the solemn promise of unveiling the geometry of the universe. Its instruments are designed not to admire single stars, but to measure the distortion of millions of galaxies. For as light crosses billions of years, it bends under gravity's hand. The subtle warping, known as weak gravitational lensing, reveals the hidden scaffolding of matter. Through these distortions, Euclid will attempt to sketch the fingerprints of dark energy across cosmic history. It will look not for sudden revelations, but for patterns in silence, for the slight tilt of galaxies, the faint clustering of structures, the whispers of acceleration woven into the very fabric of space. Soon, NASA will answer with its own vision, the Nancy Grace Roman Space Telescope. Named for the woman who guided the Hubble into being, Roman carries a field of view 100 times larger than Hubble's. It will scan the heavens with a panoramic gaze, capturing billions of galaxies in a single slow mosaic. By measuring supernovae and the bending of distant light, it will trace the cosmic expansion with an accuracy never before achieved. Where earlier astronomers looked at dozens of supernovae, Roman will see thousands. Where once uncertainty reigned, it promises the sharp precision of cosmic cartography. Every light curve, every dimming star, will become another data point in humanity's attempt to decipher the phantom. Yet not all the work happens above the atmosphere. On Earth, beneath dark skies of Chile and South America, the Dark Energy Survey has already gazed across a vast sweep of the heavens. Its goal: to map the distribution of galaxies and the way they cluster across cosmic time. Every clustering, every subtle rhythm of spacing carries the signature of expansion. For in the primordial plasma of the early universe, sound waves rippled, leaving behind patterns known as baryon acoustic oscillations. By tracing those patterns today, scientists reconstruct the cosmic expansion as though reading the faint aftershock of the universe's first breath. The survey has already revealed a universe consistent with acceleration, but with tensions, anomalies, and puzzles still unresolved. Hints that the phantom may not play by rules of simple uniformity. Hints that something deeper waits to be uncovered, and still greater ambition rises in the desert air. The Vera C. Rubin Observatory, known for its large synoptic survey telescope, prepares to open its eyes. It will not merely photograph the night sky, but will record it again and again, night after night. For 10 years, a cinematic diary of the entire visible universe, billions of galaxies, transient supernova, the faint sweep of gravitational lenses, all captured in living sequence Rubens. Survey will offer humanity the most detailed portrait of cosmic structure ever drawn, a living archive where the whispers of dark energy may reveal themselves not as anomalies, but as a rhythm woven into the unfolding story of the heavens. These are the astronomer's tools, vast and watchful, but physicists too hunt for answers. In worlds far smaller than galaxies, at CERN, protons collide with the force of stars, tearing apart matter to glimpse the fields beneath. For if dark energy is born from quantum fluctuations, then hints of its behavior might echo in the collisions of particles, vacuum energy, quintessence fields, even hidden dimensions. Each might leave traces in the spray of debris. It is an audacious idea that the fate of the universe could be written in the smallest fractions of matter. That the key to understanding acceleration lies not only in the light of galaxies, but in the silence of empty space itself. The race is not for prestige alone. It is for clarity, for survival of understanding. The universe accelerates regardless of whether humanity explains it. Galaxies slip into invisibility, horizons recede, futures vanish into silence. The only choice lies in whether the species that built telescopes and equations will face its ignorance or accept it. Euclid, Roman, DS, Rubin, they are humanity's response to the abyss, not weapons, but questions cast into the dark, not answers, but instruments that sharpen the edge of mystery. The work is meticulous, sometimes unbearably slow. Every photon captured must be corrected for dust, for distortion, for the trembling of mirrors and atmosphere. Every equation must be tested against rival theories, against the stubborn precision of general relativity, against the uncertain predictions of quantum fields. Progress is measured not in leaps, but in millimeters, in the narrowing of uncertainty, in the faint convergence of curves on a graph. And yet, in these slow steps lies the only path forward. The universe does not reveal itself in revelations. It whispers through faint distortions, subtle dimmings, slight delays in cosmic clocks. The abyss must be studied with patience equal to its vastness, for now, no single instrument, no single theory holds dominion. But together they form a chorus, a symphony of observation and speculation aimed at a phantom that resists every attempt to cage it in definition. Some hope the next decade will be decisive, that the convergence of data from space and Earth will finally distinguish whether dark energy is a constant or a dynamic field, whether gravity itself needs rewriting, whether the universe will freeze, rip, or evolve into futures beyond imagination. Others suspect the mystery will deepen still, that each answer will open into further corridors of confusion, that the abyss is not meant to be conquered, only approached, and so science stands at the frontier, eyes lifted to the sky, detectors buried underground, equations written in chalk that fades and returns. A species asking what force accelerates the cosmos, and what destiny it carries. The answer is not yet given, but the pursuit itself has become one of the defining acts of human thought, to measure what cannot be seen, to map what cannot be touched, to study what cannot yet be named. It is the confrontation of ignorance with persistence, the dialogue between silence and curiosity, the abyss, and the eyes that dare to stare into it. The cosmos has revealed much, and yet what it conceals is greater still. At the heart of its story lies an irony so profound that it humbles every triumph of human thought. All that is known, all that burns in the night, every star, every planet, every form of life is built upon less than a 20th of reality. The remaining substance of existence, the dark matter that shapes, the dark energy that drives, is unseen, unfelt, untouchable. It is as though humanity has been reading only the margin notes of a book, while the true narrative remains hidden between invisible pages. Dark energy, this silent ruler, governs not by presence, but by absence. It does not glow, it does not burn, it does not move in ways that can be watched directly, and yet it bends the future of galaxies. It dictates the ultimate fate of time. It is the most powerful force known to science, and the most mysterious. The paradox is stark. The universe is vast beyond comprehension, but the portion accessible to ordinary senses is fragile, fleeting, almost ornamental. The familiar cosmos of stars and nebulae, of dust clouds and clusters, of birth and collapse, is a thin film floating atop a depth that cannot yet be sounded. Humanity builds observatories to pierce this depth, but with every new measurement, the frontier of ignorance expands further still. Ignorance, in this view, is not a failure. It is the most abundant resource the universe has granted. Every unanswered question is a beacon calling exploration forward, and nowhere is ignorance more profound than in the domain of dark energy. Here, in this quiet ruler, lies both terror and beauty. Terror, because it robs the cosmos of permanence. It accelerates expansion, ensuring that galaxies will vanish beyond reach, that cosmic history will end not in fire, but in silence. Beauty, because it ensures that mystery itself is endless, that there will always be horizons beyond horizons, riddles within riddles. The human mind may be small, the human body smaller still, but in daring to ask what accelerates the universe, a species has stepped into a dialogue with infinity. It has chosen not to look away from the immensity of ignorance, but to seek within it patterns, meanings, truths. For centuries, philosophy asked whether the universe was eternal or finite, whether it began or whether it always was. Today the question has shifted. Now the inquiry turns to destiny, to what becomes of stars, of atoms, of time itself, under the command of a force with no name. Some futures appear cold, others violent, still others unknowable. But whichever path unfolds, the present fact remains. The cosmos is ruled by silence. An invisible hand writes the expansion of space, and nothing known can resist it. The human response to this knowledge is not despair, but wonder. For though small, though fragile, though brief, life on Earth has become aware of its place in a universe that does not yield its secrets easily. And in that awareness lies a form of significance, not in mastery, but in humility. Perhaps this is the truest legacy of dark energy. Not the equations written to describe it, not the telescopes built to measure it, not the futures it dictates, but the reminder that reality is deeper than perception, stranger than reason, vaster than imagination. That every advance into knowledge reveals more terrain still hidden. That certainty is an illusion, and curiosity the only enduring compass. In the end, dark energy is less a concept than a mirror that reflects the limits of comprehension, and the courage to face those limits without retreat. The universe expands, not only into space but into mystery. Its horizons recede not only in distance, but in meaning. And in that endless recession, humanity finds both its smallness and its greatness. Small because it cannot control, cannot stop, cannot even fully name the force that governs its future. Great because it dares to ask, dares to measure, dares to seek. The abyss does not answer, but the act of questioning becomes its own reply. And so the story closes not with certainty but with silence. The silence of dark energy. The silence of the future, the silence of a universe still writing itself beyond the edge of comprehension. The cosmos is not ruled by what can be seen. It is ruled by what cannot, and perhaps, in the end, this is its greatest lesson, that the expansion of the universe is not only physical, but philosophical, not only outward into space, but inward into mystery. The silent ruler remains unnamed, the abyss remains uncharted, and yet the pursuit continues. One question at a time, the universe expands into wonder.